pretty good. I don't want to go back to that. I hate it.
Okay.
Did y'all get the whole like, if you got a 60 or better, good job? Yeah.
Oh, that was the thing. Yes.
Yeah.
Yeah, so I already told some of the people, it was like before y'all got here, but a lot. What was I gonna say? Oh yeah, so exam one is pretty much exactly just like the foundation exam, it covers the exact same topics. Maybe you might have a little bit more solubility kind of put into it. So this is your time to, you know, read or gather some strength in the topics that you have for a weekend, and so you can bounce back the next exam. But yeah, so keep studying, don't give up, you got it. Today we're going to do empirical molecular formula practice, and what I want to do is I'll do one example, and then I'll give y'all a chance to work on the second example by yourself, and just some time to do that. And then we'll reconvene and we'll discuss. I'll ask someone randomly, or if you want to volunteer, you know, how you got that answer, and then everyone else can either agree or disagree that they got the same answer. And if you have questions, you can ask. Maybe you missed and you ask questions, you can ask us or your classmates or your fellow students. All right, does that sound like a plan? Okay, so first one, it gives us the percentages. Typically, you'll be given a word problem. This is not a word problem. So this one gives us the percentages just flat out, but you can still do it without all the extra words in the problem. Let's go ahead and start. So do y'all know the first step when it comes to finding the empirical and molecular formula? Go ahead.
Percent to grams.
Okay.
But like took it the same numbers.
Yeah. So and why do we want to get to grams?
We have the molar mass, grams over moles, and then it wants like the, so and then we cancel grams out. Right?
So yeah, so we do everything in this class with moles. So we want to get to moles eventually, right? So with that, the only way to get from moles is if you have grams, right? Because you have the molar mass. So you want to get from percents to grams, so that way we can go from grams to moles. Grams isn't our end destination. It just is an intermediate thing. So
Something you said was very intriguing though. You said convert the percent to grams, but it's going to be the same number. Why'd you say it was going to be the same number?
Oh wait, I'm doing the calculation right now.
what was that?
Is that out of like 100?
It's well, they all have to add up to 100%, but when you convert from percents to grams, the easiest thing to do is to assume a 100-gram sample. You can assume a 500-gram sample and you'll get the answer right, but it makes it more work for you if you assume a 500-gram sample. So if you assume a 100-gram sample, you automatically know that 26.4% of 100 grams is going to be 26.4 grams. So make it easy for yourself and assume a 100-gram sample when given percentages. So that way your percentages turn directly into grams. Does that make sense? Yeah. So we're going to assume a 100-gram sample. So if our 100 grams is 24.6% carbon, that means we're going to have 24.6 grams of carbon. Does that make sense? Yeah, cool. So 26.4 grams carbon. Make sure you write your units. We have a molar mass of 12 grams per mole for carbon, right? So this is from the periodic table. So 12 grams of carbon for every 1 mole of carbon. And, well, that's it actually. So we got the moles. So what is this when we put it into 2.2? Cool. So 2.2, and do you have an extra decimal in there, or 2.2 moles? So that's carbon, and we do the same thing for hydrogen. So 3.3% of 100 grams is just going to be 3.3 grams. 3.3 grams of hydrogen. We have 1 gram for every 1 mole of hydrogen. And that'll give us that. So we end up with 3.3 moles of hydrogen. And then we'll do the last one. which is 70.3% oxygen. So if we have our 100-gram sample and it's 70.3% oxygen, that means we just have 70.3 grams of oxygen. Divide that by our molar mass of 16 grams per mole of oxygen. And we will get a number
4.394. I just rounded the last one.
4.394, perfect. And that's moles of oxygen. So that's the first thing. You converted our percents to moles. If you had been given grams, then you wouldn't have to assume a 100-gram sample, right? Because it already gave it to you in grams, you can convert it directly to moles if you were given grams, like in problem number 2. Any questions so far? Do you all know what we do next?
Now we divide by the smallest number, so it's 2.2, and for each one.
Why do we do that?
So we find the what is it, molecular formula? Like how many, like the coefficient. That's not.
Why does dividing by the smallest one? Why do we choose the smallest one? Anyone?
It just works out. That's, I don't really know why.
Like, what's the definition of empirical formula?
Oh, it's the least amount of coefficients like that you can have. So,
Or what's a more fancier way to say that?
how do you say it?
Most simplified. So the empirical formula is the smallest whole number ratio of your elements in a compound. So that's basically what y'all said, but a little bit more textbook definition.
So we're gonna divide by which one?
2.2.
Yeah. 2.2 moles carbon, and you don't have to.
So you get a 1.
This is obviously gonna give us 1, the ratio of 1. If we divide that,
And 1.5.
so what?
1.5.
1.5.
And then the other one is just 2. Or is 1.
2. So you said it's 1.99 in the calculator. We just go with 2. All right, we're not gonna worry about the decimal. All right. So now what do we do?
So now we have to break the 1.5 into.
All right. Anyone else want to ask a question? It seems like he knows how to do it.
Sorry.
Okay,
Go to.
go ahead.
Multiply by 2.
And why? Go ahead. Go ahead. Sorry.
1.5, so it means not more numbers.
Yeah.
Multiply everything by 2.
Yeah, because right now it says we have 1.5 atoms of hydrogen. Is that possible? So we want to get to the smallest whole number, so we multiply by 2 to give us 3 for that, but we have to do it for all of those. We can't just do it for hydrogen, right? So in a different color, we're going to multiply by 2 for each of these, so that way we can have a whole number of hydrogen atoms, not 1.5 hydrogen atoms. This is going to give us 2 carbons, 3 hydrogens, and 4 oxygens. So this is the amount of atoms in your empirical. Okay, empirical formula is the most simplified version, right? So it'll be C2H3O4. So that's the empirical formula. And we can actually just write that down here where we want to. So how do we get our molecular?
You're gonna take the molar mass of the empirical formula and divide the given molar mass by that molar mass.
Yeah, exactly. So what is the molar mass of the empirical formula? 91. 91. Okay. 91 grams per mole. So when we take this, we're going to be working up here in the top right. Y'all see that? No, it's a little bit. So we just take the molecular formula mass, the molar mass, and we divide it by the molar mass of the empirical formula, which in this case it's 91 as well. So you just get a ratio of 1. Which, what does this tell us about the molecular and empirical formula? They're the exact same, right? So our molecular formula is going to be C2H3O4. All right. That looks good. Any questions on that before I let you? Yeah.
So the empirical formula can be like a different amount of molar mass?
Yes.
Or is
Like,
it always gonna be like the same, like?
yeah, so I see what you're saying. So in this case, the empirical formula is the molecular formula, so the empirical formula mass is going to equal to the molecular formula mass.
Same thing.
Not all the time. In certain cases, the empirical, let's just say the molecular formula is 100, the empirical formula is 25. That means that you have to multiply the empirical formula by 4 to get to your molecular. And you'll see that later on. Okay? So we'll do an example. So if y'all understand it, if there are more questions, I'll have y'all do number 2. Let's do a testing scenario. I think 3 minutes is more than enough. If you go over, that's totally fine. But let's see how y'all can do with the 3-minute clock. It's just 12. What was the other? Apartment 12. Okay, so yeah. Okay, so what? Oh, wait, just kidding, we're on number 2. Oh, okay. I was apartment 12, I don't want. Are you able to make a Google form really quick about what topics they want us to cover? Right. Like, that's the only question. All right, we're gonna. Are you able to extend this one? Or is that not a thing?
There's only one display. So
That's crazy.
that's what I can do it.
What is that?
I think it was a projector. Let's see.
Time was at 20 seconds, who's done? Okay. I only saw like 4 hands, oh, 5, okay, cool. Who's not done? Okay, if you're not done. So are you done because you didn't have enough time or you didn't quite understand how to go about it? And it's okay to be honest, if no one, I'll kick someone out if they make fun of me, okay? So.
I just got, okay, actually, it's quite I don't know if you're supposed to on up to 3 or.
Okay, I'll do the math really quick and see where, did anyone else have that same problem? Yeah, okay. So first step was we were given grants, so we do what? You convert to moles, right? We don't have to assume 100-gram sample because we were already given it to us in gram. So we just divide by the molar mass to get to from grams to moles. So 12 grams for every 1 mole of carbon. And what number does that give me?
6.8.
6.8 moles in carbon. And we'll do the same thing for hydrogen, so 18.2 grams of hydrogen divided by 1 gram for every 1 mole of hydrogen is just going to give us 18.2 moles of hydrogen. All right, so that dark blue is going to be step 1. All right, step 2 will be in red. And what did we do for that?
5%.
Yeah, so the smallest number is going to be 6.8. That gives me 1 carbon here. This gives me a little over 3. What did it get?
2.66. Yeah.
Okay. All right, that's fine. Okay. So now we know that we can't have 0.66 of a hydrogen atom. So how do y'all go about making this full number? Okay. That's you multiply it by 3. I don't know if we want to assume that it's like they give you these numbers to add up to 2 point or to be multiplied to 2.66 and stuff. So I don't know, it's too much of an assumption to bring it down to 0.5. So like if it's 2.49, which we'll see a lot, that's 2.5 you can round. That's something like 2.66, you're going to not want to round down to 2.5 or to any other number, okay? So I wonder if you got the same answer. We'll see. So someone said multiply by 3. Do you all agree with that?
Yeah. We're gonna get you 7.98.
80 equals 87 point, wait, 87.
No, I said 7.9.
Oh, 7 point, okay, so
Yeah.
8. Just gonna run down to 8, all right, so that's 8 hydrogens, 3 carbons. So this is going to give us an empirical formula of C3H8. And does anyone know the name of that compound?
It's you're trying
It's actually, it's named different because it's a hydrocarbon, so it's gonna be propane. You ever use like propane gas on a grill? So prop, because it's 3 carbons. Ane, because if you draw it out, there's only a single bond. And you're not gonna get it up this class, I would just, you will eventually, for all the people that have to take academic chemistry,
You know, if they had double or triple bond.
then it would have less hydrogen.
Oh, right, but it's the 1-to-1 ratio and with the double bond,
Yeah.
it's like a 1 half, a double bond.
Okay, so what is the molecular or the molar mass of the empirical formula?
It's
44.
yeah,
44. And again, we're getting all this stuff from the periodic table. Yeah. So now what do we do? Because we want to find the molecular formula.
so
Divide the molar mass of the molecular formula, which is 132, by the molar mass of the empirical formula, right? So we're going to get 132. It's going to be up here divided by 44, about 3. So then we multiply the empirical formula by 3 to get the molecular formula. So if C3H8 is multiplied by 3, so you get C9. H20. Any questions on that? Or for
Oh, like
Wait.
if I do gray area, like when it comes like the decimals, I'm like, where you rounding to?
yeah, that's a good point. 2.66 is too high to round down to 2.5. It's too low to round up to 3 or 2.75. Like all these numbers, at least if there's not a mistake in the test, they should not, there shouldn't be an error. So you like, if it wants it to be 2.5, it's going to be 2.49 or 2.51. Does that make sense?
Yeah.
Like you won't get 2.66, and even if they meant for it to be 2.5.
Okay.
Yeah, no, okay. make the mistake now so you don't do it later. That's good. Any questions? All right. Can we do 3? I'll give you all, is 3 minutes good last time? Or was that too long? Or are we trying to make it?
We could go a little fast, as long as you give it.
I messed up, I'm telling you. Go again. All right, let's do 3 minutes. The first one finished, we'll get a, well, you already finished. Nice, nice. Yeah, I'll be, in your room up there.
Yeah.
The office hour or session? Cool. How do you like it?
I like the adult sessions just you and kind of what I can talk about in my session.
Like, cause a lot of,
We're kind of going over the same.
yeah, wait till next weekend, that's when it gets really fun. It's all just the first 5, 6 weeks of Gen Chem when they're all just the same thing over and over again.
Yeah, it's like I'll be in my sessions and helping my class.
Nice, that's great, yeah. I just want to come with great.
Oh,
Or you're a master at this. Yeah, okay. Is there a topic you wanna go over? That's not this, or do y'all wanna keep going over it?
Gas lines. No, we're not there yet.
Yeah, there's a couple more weeks. Relations.
Gas lines.
Oh, dilutions.
Okay,
yeah.
that's,
The TV. The next one. The brightness. I wrote the percentages on the board in case y'all need to see them again, and the molecular mass, the molar mass is 682.8. I'm going to look for other problems. Feel like feel about polarity problems, solutions for geometry. Taking your head out and you don't want to do it, or taking your like I don't know how to do it. That's okay. All right. So maybe that's something we can do next. Give me a second to find some problems like that. Alright, got some good problems, I think. Might give some of you, more of a fun time here. Alright, let's go ahead and do the last one here. And then we will move on to interesting stuff, more interesting. Alright, I'm not sharing this here. Who's done and who's not done? Well, I should ask one of them. Who's done? I was pride. Okay, yeah, sure. If I say have pride, make sure you raise your hand so I can have a better idea, because it's kind of hard to count. All right. So you're given percentages this time, so what's the first thing we do? Yeah, convert to gram. And how do we do that? 9,000. We're given percentages. Assume 100 gram sample. That's what I was thinking. Oh, okay. Yeah. So assume 100 gram sample. That just tells us there's 20.2 grams of sodium in that sample, and then we know that the molar mass is around to 23 grams per 1 mole. And that's it. And y'all do the math, obviously below the rest. $32.
Yep.
Yeah.
What do we get for those three?
It was 0.88. And then 1.17. 2.64.
2.64. Okay. Then we divide by the smallest number. One. Give us 2.
1.33.
1.3. And then here,
3.
3. All right, so then we multiply by what to get to the nearest whole number? 3, right? So times 3 times 3 times 3. So give us 3. This will give us 4. This will give us 9. We get an empirical formula of. So we're not doing that. So sodium, 3 sodiums, 4 sulfurs, and then 9 oxygens. Okay. So that's our empirical formula. And then we get to our molecular formula by, don't ask. Put someone in the back. After this row, after this. Okay.
Get by finding the mass.
Yeah, so the 340 is the mass of the empirical formula that you got that from this empirical table. You get 2, so that means the molecular formula is has twice the number of atoms than the empirical formula. Then we multiply every number in the empirical formula by 2 to get the molecular formula. Any questions on that part? There's no question. Move on to different stuff. So not ionic equations. I'm gonna do number 2. I'll give you a second to read it.
Is that on the other paper or is it just not on there?
It's not on there. Oh, okay. Like, you won't have this on your iPad, but we can definitely send this out to you. So 42.5 mils of, what's the name of that? HI. Yeah, hydroiodic acid is completely neutralized by 56.9 mils of a 0.79 molar barium hydroxide solution. What is the concentration of the original hydroiodic solution? So at first glance, you might be like, what do I do? How many of y'all are like that? Don't worry, I was once in your shoes. It's asking for concentration of HI, of the original HI solution. What's the equation for concentration that we deal with in this class?
Is M1 and B1.
No, that's dilution.
Moles over liters.
Moles over liters, right? Because we deal with molarity as our concentration. And molarity is equal to moles of solute divided by liters of solution. So we have molarity of HI over the support, right? This is equal to moles of solute, in this case, moles of HI, if that's what we are looking for, divided by the liters of the solution. All right. So do we have the volume? Because we're looking for the big N on the left side of the equation. So we are missing two variables. Do we have liters? Do we have liters of that original HI solution? Do we?
You have to convert it, right? You have to convert it.
Yeah, we do because it's in milliliters, but like she said, we're gonna convert it and we get liters. So I would say we do have that information, right? Because it tells us that we have, of the original solution is 42.5 mils. So that means we're only missing one variable, which makes our jobs a lot easier. 0.0425.
Would it be safe around the 3, 4, 3?
If you want to get the wrong answer on the test, sure. But if you want to get the right answer on the test, don't round into the variance, all right? But I don't think any of y'all want to get the wrong answer on the test. Right? Okay, so how are we going to get moles of HI? Well, so it's always helpful to write the chemical equations that happen. So this is, we have hydroiodic acid and barium hydroxide is a base. So this is an reaction. What kind of acid-base reaction, right? So HI reacts with barium hydroxide to produce, oh, we're not there yet. Okay, to produce what? What happens in acid-base reactions?
Double displacement.
You get
Yeah,
hydrogen.
but what are the products that you're gonna have to know? Water is one of them, so water. And then babies, salt.
Liquid.
Liquid, wait, liquid solid.
Well, it's L. Acres.
Oh, you mean aqueous?
Well, in this case, it would be aqueous, liquid.
Liquid. Oh, yeah. Liquid. That's on that. Normally water is like on the other side.
I'm sorry, I don't know why I think burns.
I mean, you can put it on that there if you want.
All right. Now, what do we do when you have a chemical equation?
Balance.
We balance it. So how are you gonna balance it? I know for a fact we have two iodides on the right, one on the left, so we should definitely probably put two in over here. Does that balance at all? Need two molecules of fire, right? That's gonna balance it. So we need to get from moles of barium hydroxide. How do we know that? They give us enough information to calculate the moles of barium hydroxide. Do they or do they not? They give us the liters and they give us the molarity. And the equation for the barium hydroxide would be molarity of that barium solution hydroxide is equal to moles of barium divided by liters of solution. So we're looking at equation. The red one right here, and everything that's for the red one is gonna get highlighted. We have the volume. Right? Milliliters, but we can get to liters, we know how to do that. And we have the molarity. So can we calculate moles of barium hydroxide? Yes, right? And if we have moles of barium hydroxide, how would we get to moles of the HI required to completely neutralize that solution? What is the way from one moles of one thing to moles of another thing? Molar mole ratio in the chemical equation, right? Feel like I've lost someone or some people so far. So if there's any questions, ask now or Bruce says.
Forever hold your peace.
Yeah.
This is not what I say, that's what the big man upstairs says. You pay attention to the big man.
All right. So, do y'all have questions before we get going? So they gave us enough information. They're asking for the molarity of HI, the original solution. They gave us the volume of that solution. So all we need to find is the moles of HI. They didn't give us anything, they didn't give us grams or anything to calculate the moles of HI. So the only way to get to moles of HI is utilizing the other information that we got from the problem, which gives us the ability to calculate moles of barium hydroxide. And if we know the moles of barium hydroxide using the balanced chemical equation, the mole-mole ratios in that, we can get from moles of barium hydroxide to moles of hydroiodic acid. Does that make sense? No? Yes, it makes sense. What do you- All right, let's go through the problem all the way and we'll see. Then maybe you just have to see it and then maybe that'll click. So again, we're trying to solve for this. We're just using one variable, the moles of HI. They gave us the information, the molarity in the liters to calculate moles of barium hydroxide, and using that we can convert to moles of HI through the chemical equation. So we're going to solve this for moles. So moles is equal to the molarity of that barium hydroxide solution. Times the liter. All right, so we're given the molarity of 0.79 molar, and we're going to multiply that by the volume in liters. So 0.0569 liters. And Nicholas, if we did this, what would we get?
You would get 0.0449.
Moles of barium hydroxide. Okay. So we just found moles of barium hydroxide from using the information of the solution of barium hydroxide that we're given, right? So now that we have moles of barium hydroxide, it's something that we've done since we calculated the limiting reagents. We convert from moles of one thing to moles of the other thing, just to balance chemical equation. So how many moles of barium hydroxide react with how many molar? I just said that to them. What's the molar mole ratio?
It's 2 to 1.
Yeah, so for every 2 moles of HI, 1 mole of barium hydroxide reacts. Okay. So this is to get us from moles of barium hydroxide to moles of HI. That's all we need to calculate this right here. Because you already have this liters, we just need the moles. What do we get in this part?
Yeah, 0.0899. 02, you want to include that.
0.09899.
Oh, 899.
Okay, or
That goes over, and that's mole right there.
That is mold. Alright, so stuff highlighted in yellow is everything that you're gonna need for that second carbon, so. This is exactly where we're getting everything. Okay, so we got the molds through all that math we did. The liters was just given to us, and the liters we converted that to liters. So pretty much everything highlighted in pink, or circled in pink, is to get that mole of HI. If that helps you kind of understand where everything came from. All we do now is we're gonna go up here to the top. Molarity of that HI solution, the initial one is going to be the moles of HI that were in there over liters. Divided by the liters of that solution, the original solution, not the combination of the two volumes. Okay, so just the original solution was 0.0425 liters, and
We get 2.115.
2.115, 2.2, or 2.1. Yeah. This is molarity of the HI. All right, does anyone have questions? You're gonna see a lot of this on the next exam.
You follow the significant figures in my years, right?
I didn't follow this. Yeah. I guess technically you should have two signals. But,
The most of them will be anti-push, right? But there'll be a couple that are like the type ones.
yeah, I thought. All right, so anyone have any questions? Bro, yeah.
Why would you choose something?
Because we look at the numbers that were given to us in the problem. So we have 42.5 that has 3, 56.9 that has 3, and then 0.79 that has 2. Because we don't count that first zero, even though there is a test. It's just the one of the sig groups. So the least number would be 2. Out of all of them. The people in the third row. Thumbs up. Thumbs up. Keep working on it. This is being recorded, right, Rich?
Yep,
Okay, so yeah.
it's so bad.
So we'll post this on YouTube and you'll be able to watch it again, try it yourself, and we'll send out this worksheet, and there's a lot of these types of problems on there that if you didn't understand this, have it, better go at a different problem or the same one until you get this down. This is very important. I would just type in solution stoichiometry on the internet if you want to find them. If you're using your stoichiometric ratio in solution-based problems. So yeah, I think solution stoichiometry kind of problems you'll get a lot. We'll stick around for a couple more. Like, is it?
We got it.
Oh, we got a lot of time.
I can't go ahead.
Thank you.
I want to go over another one, or was that too scary?
Was there any other topics that we could have? Other than that?
You want to go over this, or do y'all want to go over something like this, or different, or just throw out a topic that you need help on?
Like, what do you absolutely not get now? Like, you walk into class, and then professor going over something, and you have absolutely no clue what's going on.
Okay, guys, we're not gonna shame.
I'm not even
Understand is the equation you were talking about earlier, the M1, M2.
M1 V1 equals M2 V2.
Yeah.
Yeah. So
No. It's like M minus M1 or M2 or something like that. I know it has something to do with percentage.
Isotopes.
Oh, yeah, isotopes.
I think it was also.
is it?
It's not concentration, I know that one, but it's the.
It's like percent abundance.
Yes,
Oh.
that's what it is.
That was
You'll not understand that?
No.
Alright.
I love them.
Alright, give me a second. See if I have any percent abundance problems on hand. This is isotope problems.
Ones that I see this. Or is it? I don't know, but this girl, yeah.
Just gonna make sure the atoms. are on. I'll give you the product on this one. So, you might have to share the screen again. We're gonna just make up our own problem because
The internet's making it complicated now.
I hope it's. Yeah.
Alright. Let's say this. There are 3 isotopes of carbon. There's carbon 11. There is carbon 13.
But we don't like.
And there is carbon 15. So let's say that the percent abundance for carbon 13 was 25%. And the mass of carbon 11 was 3.5 AMU. And let's say that the mass for, what's it called? Carbon, or carbon 13 was 5.7 AMU. And let's say the mass for carbon 15 was, let's see, 2.345 AMU. These are the isotopes. What is the question? Question is, I want y'all to find the percent abundance of carbon 11 and carbon 15. Both.
who knows how to do this? Well. I think we did a problem on a similar one last week, yeah, but when we calculate the percent abundance of the other 2, when we're given the mass of all 3 and the percent abundance of 1. You all recall that? No? Does anyone? All right, absolutely anyone, 'cause I was gonna have y'all work in groups, I was gonna say, hey, the people that know, can team up with the people that don't know.
Yeah, it's like this, of all the mass times the percent.
Yeah.
And then you just. All
right.
X, Y.
How about y'all work together, y'all work together, y'all work together? Just for a little, like 5 minutes. And then like Rick will go ahead. And then so it's all together.
How it works, except that the ads of top have to do with right? Once they I remember Alex, basically it would be like, they gave me like 2, so I'm asking her, and they were going to find that. And then the DMP that you multiply those, and then add them to the other 2 that were multiplied, and then you would. Yeah, it's hard.
Yeah, it's
Well, and one is not C2 bracket plus the other one. Whatever. And then you get a general. No, it should be. These multiplied by. Oh, and then so, this is probably 100%, right? And then this one has to be, like, the other two have to equal 75. So they're not like. Oh, so we don't know the percent of the other two, like one could be a higher percent than another one. Does it have to add up to 75? Yeah, well, yeah, but, well, we have 25% right now, so the other two have to be 75.
Yeah.
You haven't done it backwards. So. That's gonna
That makes sense.
So this one is going to be.
It's on Friday. the next-
Yeah, Friday, 1 to 2.
Hey, Rich, I think you need to give them an average atomic mass.
Yeah.
That's what, yeah, that's why we're.
Oh, I thought y'all could just look on the periodic table for carbons, that's why I didn't give one.
But your AMUs wouldn't match up because carbon would have. Like, carbon 13 would have a mass around 13 AMUs. And not 5.7 AMUs.
This is the problem with creating my own. Stuff like this. You know what, let me,
What if you just change, what if you just put a atomic mass somewhere in the middle, like four falls apart?
let's say the average atomic mass, I'm gonna abbreviate it with AA, this is not alcohol, it's on, this is average atomic mass. It is 4.75 AM. Sure, we can do another one. I'll actually find like a legitimate problem.
Percent abundance of one times the mass plus the percent abundance of two times the mass plus the percent abundance of three times.
We worked out a problem in the past. The YouTube video is probably up, so you can look at that one too. And then this one will also.
That is another one for the email.
Yeah, it's team entropy. That's the. Like team as in teams and then entropy as in ENTRO.
Like.
Well, I'm subscribed when we get a chance.
This is the only thing I'm pretty much understanding. And like. Yeah, I don't know if the rest was. And then like when you-
This is kind of a complex variation.
that was a long time ago.
Alright, you ready?
I think we can go over because we've gone over last time and no one walked in. So I think there's a.
And I cleared out my next hour, so we good.
Leaving your team?
I just had tutoring right before I came here and then came here, but yeah. Absolutely.
All right, have a good one. How's group 3 over there?
We have the band.
Yeah. You wanna go see where they are, Rich? I'll go walk around too.
Well, I have an idea, so right, so this is 25%, these two have to equal 75, so it all has to equal, right? Yeah, and then once we equal that. Yeah, but they're not like both 50%. Yeah, but I don't, that's the part, like, I don't know how to.
Y'all don't know the equation.
Oh, no.
Oh, I can.
Times percent mark, and then bracket plus M1 or M2 times percent 2, but if you have 3, it would then be. So, oh, okay. And so then you don't have a number, we're just like X. So,
Yeah, exactly.
So it'd be like 3 points, but oh.
And this is all equal to your average.
Right, okay, so 3.5x bracket plus 20 or 0.25
So you have the numbers down.
times.
You get your bracket, your variables, because you know that the two missing abundances are not supposed to be the same. You can't give them X and Y. You get it, you give them different variables.
Plus two,
Maybe some, I still.
B.
That's what the.
Yeah,
How common.
equals to 4 point.
So. Here's the. So. If you know that, anything you do, our atomic mass.
Right?
Like, everything.
Plus the X and B, so yeah.
And then.
So, the way we solve
But-
this is, we call it a weight, you know how I'm like.
so like Nicholas said, we know that,
It's the same thing, like.
we know that the two missing abundance have to equal 75%, right? So we can say, so, carbon 13, the one in the middle has a percent abundance of 25%. That means the rest, the other two have to add up to 75%, so that way the total is 100.
You can make.
Does that make sense?
Well, kind of off topic, but is that true for all isotopes? Because I know carbon has, I think it's like 14 isotopes.
Yeah, they all have to add up to 100% because that's what makes up everything neat at first. So we know that X plus Y has to equal 0.75. Okay. Because they both have to add up to 75%. So X plus Y equals 0.75. So if you just want to have one variable in your equation, you can solve for whichever one, but you'll do Y equals 0.75 minus X, and you can plug that into Y. That's just subtracting X to the right side. But you can get this as long as you understand that X plus Y is equal to 75%.
Seven, X, B, equal to
How do we make something like that?
4.7.
All right, where are we at?
Well, I'm doing like algebra, but, and then divide by 7.2, and then we have the X equal to.
Yeah, so if you do that, that doesn't necessarily mean that
I'm wrong, but
those other abundance are exact.
Oh, I did like, this number one, you know, we have X at the, plus number two, 0.25%, plus 23. So we found one, B, variable equal to that. And then I'm solving for it, and then I have X B to that number. And then you have these just have to equal up to 75%. It's just kind of like. No, this is exact, I'm still, I think I'm wrong. No, yeah.
Plus 30. Afterwards, multiply it.
Get like.
I'm not.
We don't know that either, so it makes sense. Just that. One variable.
Well, I can.
I did it.
That X plus Y. Right now, 100 minus.
I would
What they say is the last day. Okay. Well, maybe like, is. Yeah. So if we don't want to, that's a lot. Or others.
Now you have all the things that.
25% plus to solar. So basically, I solve for
Gotta make sense.
solve for line, I solve different ends. So it's,
Completely off topic, but how would you, if you could, how would you switch your gym chem professor?
so like one side.
Would you switch your gym?
But that one side, I like.
Technically right now, could you technically like sign up for the other one, but still be like, have the same grades and
And
everything?
then I just kind of plugged it in.
What about like exams, the foundation, with that?
And
But not about like the time.
plus.
Yeah, well, then I think.
If you don't understand,
And plus.
like.
So. Yeah.
I was telling her, I was like.
Shaders are doing like 40, 60. So.
Well, the good thing now is that-
And then some of that one is-
When I push the back.
Yeah. Well, not 3.5, and then,
Well, yeah, I want
Out of all the defenders, there's only one that will really care and actually. You all need to find out because it's not.
Yeah, well, that's what I was gonna say, yeah, I was like, yeah, the videos.
You're not dropping. the fourth.
No, 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 no.
Right, okay,
I've done 81 of these.
okay. Before you say anything, that's not bad. Okay, so. Okay.
I'm just, I don't know what, yeah, I was thinking of but I ran, I did not study. I was higher.
Yeah, of course, you always want to. Want that, you want to, you can, there's a downside. And look at the 30%. Just, you know, probably. Thanks for everyone, if y'all wanna go to your, I don't know about the professor, but Dr. Armand will like to see your exam. After exam, but like any other ordinary things, no.
Yeah, but no, I took things. But I was like, well, and then now, I'm kind of like, well. Cause I like see things, but actually, there, that's what I like a good chapter. Like, y'all are talking about this, but we're doing, like, let's see, let me recover class stuff. We're on chapter 30, we're on empirical, yeah, this is recovering empirical formula. The thing.
I'll figure that part. If anything, you're supposed to be starting after the foundation, you can do a brief run through chapter 1, chapter 2, and chapter 3. Chapter you're already on chapter 3. Well, I mean that you're going to come to the bottom.
I mean, yeah, no, it's not far, I was like, yeah, thanks, and I'm like, I actually kind of think better, it's like more.
Yeah.
Enjoyable, but, so now. Yeah, I gotta go. Not really.
But I
I ordered, I'll be on Friday.
Yeah, of course, I'd go. We're two, how are we doing? Or actually, no, I understand it, like, very. I say. Well, like. Where are you lost? Okay, so I really. All equals. 25%. The top of that. There's 7. Percent. Times 3.5. This is number the percents. Yeah. Yeah. And then you saw the next on Y. And you know, one. All right, real maybe you're more. Well, it's so active. Sorry. So you had some. Right. Yes.
Okay.
Okay. Yeah, go on. Excellent. We know that the percent of each.
Go ahead and solve that out. You basically got it.
Not of X and Y, because X and Y. Yeah. Which is what? Oh, we know that carbon 13, a bonus of 25%. So that means the remaining 75% is between X and Y. We X plus Y must equal 75%. Or you can say X plus Y equals 0.75 for this, so this. And if you have an unknown X or X here and an unknown Y here, and you know the relationship between X plus Y equals 0.75, you can solve for one of those variables. So that we can plug it into the win equation. Y equals 0.75 divided by that. Y equals 0.75 minus X because you have one. You want to take a picture? Sure.
I will do that.
I'll picture
You'll let you know on the road myself. Here's one.
Right now.
Right, we. It's 1025 minus X. So yeah, you know, they're pretty on the right track. So yeah, you. Now we'll find out soon when I see. Yes. Or you really don't, because since you have X, right, whatever you got right there, or whatever you have right here, that's X. And then you gotta plug it back into this equation to find Y.
Thinking good thought. I'm just doing the math. So the equation is here. Come up here. Come to the board.
Here's something like one thing.
So the average atomic mass, which he gives us AA 4.75, is equal to the mass of one times its percent abundance plus yes, that's percent. Yeah, times percent abundance. and then times 3 times its percent abundance. Let's just say M1 is the one that we know everything. We know that its mass is what? 5.7 times 3.5. Yep. So we're gonna convert this to a decimal just because if you put it in as 25% in the calculator, it'll work. But if you forget this percent sign in the calculator, then it's like you're doing 5.7 times 25, not 0.25. Right, next, let's say M2 is the partial, so plus 3.5 times its percent abundance. Oh, but we don't have that, so X plus 2.345 times Y, exactly. You cannot put X and X here because we know that these are not the same, so X and Y. How do you solve an equation with two variables, you might ask, which we forgot to do this, which is 4.75. How do you solve an equation with two variables using algebra? System equations. Yeah, that's one way, and that's the two ways. I like to find the immediate relationship between X and Y. So you know that the total that's have to equal 100, right? Yeah, so let's just convert this instead of 100, let's do 1 because that's just X. 1. Yeah. Yeah. And we know that one of them is 0.25, so this gives us 0.75 left over. And we know that this is equal, has to be equal to the sum of X and Y. So this relationship between X and Y will help us solve this second equation here because we can't solve for two variables in algebra. You have to get one variable and then you can solve for that one. So which variable do you want to solve for, X or Y? You want to keep X or Y? Okay, so if we want to keep Y, that means we need to eliminate X. That means we have to solve for X. So we get X equals 0.75 minus Y minus Y. So that cancels. So now we can put this there. So 0.75 minus Y. So rewriting, we get 5.7 times 0.25 plus 3.5 times so 0.75 minus Y plus 2.345 X. So that now only has, sorry, that should be Y. All right, times Y. So that now we only have one variable, unknown variable. So now we can solve this problem. And if you get a calculator, like whatever you have, if you have one like this one, you don't have to do all the algebra. You just put it in here and you press solve. It'll do it for you. So 4.75 alpha equals 5.7 times 0.25 plus 3.5 times 0.75 minus alpha X plus 2.345 alpha. So you said and I put X instead of Y. It's the same. It will be the same. So
this should be, if you're gonna do it that way, you're gonna plug this into Y.
yeah, sometimes it would be 2X though. All right, so if not, then you have to solve this by hand, which isn't the worst, it's just not the thing you want to do on a test. It takes a lot of time, but let's simplify this. So we would get 4.75. We know that a number times a number is just a number, so we would get minus 5.7.25 equals. We have to distribute this into there. So 3.5 times 0.75 minus 3.5 y. So plus 2.3 y. So now these two can be combined together. This is just a number times a number, so we would take that to this side. And then you would eventually get one number here. And then you would get one number after you add these two y's. And you would end up with a nice. Wait, we move this to the other, move this to the other side. Oh, yeah, because this is just a number times a number, so it's just another number. So we would just subtract this to the other side. So minus 5.7 times 0.25 would go right here. And this you can't subtract or divide this 3.5 out because you would have to divide the whole side by 3.5, which then it would cause problems over here. So for this one, all we have to do is just distribute it in. So we get 3.5 times 0.75, 3.5 times y with the negative sign, and then plus 2.345 times y. And then you would just isolate your numbers on this side. So you would again subtract this over to this side, add these numbers together. And you get y. Yeah, once you solve for y using a little bit more algebra, you'll get your y, and that's going to be the percent abundance of the third one, carbon 15. And then in order to get the last thing, it's just, if you know why, no, that's even this. Think on that, try to do it by yourself when you get home. Or right after this. Just because walking through it with someone is good. I need to do it by myself. But yeah, in order to really understand this, you have to be able to do it by yourself. But yeah, keep working, man. Don't give up.
Oh, yeah, I need to find out which is the problem, because mine was a black.
Yeah. Yeah, I was looking skeptical when you said the first one had I was like, wait, protons and neutrons are 12 or 11. That means it should be at least 11.
Yes. What else make?
11. Negligible.